What unsettled me was not the cleverness, it was the patience. In a red team replay, I watched an LLM agent move through a compromised container. It enumerated the environment, found the cloud metadata endpoint, pulled temporary credentials, and started listing S3 buckets. Flat, tireless enumeration at a speed no human attacker would bother to sustain. No typos, no hesitation, no coffee break. In May 2026, the first known zero-day two-factor authentication bypass developed with AI assistance was used for mass exploitation. The Marimo vulnerability disclosure documented post-compromise movement where an LLM agent extracted cloud credentials and SSH keys before defenders identified the intrusion. These are not theoretical scenarios. This video builds the defensive playbook. 3 things have changed about attacker economics, and all 3 matter for how you build defenses. First, the speed of post-compromise. An agent can traverse from code execution on a container to cloud credentials to data enumeration in seconds. The detection window has compressed from hours to seconds. Defenses that assumed a human attacker taking time to read output and make decisions need to be recalibrated. Second, tirelessness over breadth. A human attacker prioritizes targets. Time is limited, attention is finite. An agent tries everything within scope, in rapid sequence, without fatigue. The effective attack surface breadth is dramatically larger. Third, adaptation in the loop. When the agent hits a blocked path, that is not a dead end, it is information that informs the next decision. The agent reads the 403 response, logs the blocked path, and tries an adjacent approach. Blocked controls are as visible to the attacker as they are to the defender. None of the underlying techniques have changed. Credential theft from the cloud metadata service is ancient. Listing storage buckets is ancient. What changed is the cost of executing the full chain competently. Defenses calibrated to the cost of human attacker time need to be recalibrated to machine execution cost. To build the right defenses, you need to think like the attacker's agent. Let me walk the observe-decide-act loop. The agent starts with initial access, code execution on a container, a web server process, a Lambda function. First actions: enumerate the environment, identify what services are reachable, determine the workload's identity. The highest value link is the jump from code execution to valid cloud credentials. On Oz, an HTTP GET to the instance metadata service endpoint, 169.254.169.254/latest/metadata/em/security credentials. On GCP, the metadata server at the same IP range. Every major cloud provider has an equivalent. If that hop succeeds, the agent has temporary credentials with whatever permissions the workload's IAM role carries. From there, enumerate accessible storage, extract secrets from secrets managers, map the network, identify adjacent credentials, stage exfiltration or lateral movement. Everything downstream of the metadata endpoint hop depends on it succeeding. The credentials returned define the blast radius of the compromise. This is the highest leverage point for defenders. If you close this single link, the agent has code execution but no credentials, which dramatically limits what it can accomplish. Layer 1 of the defensive posture is blast radius reduction. The goal: make the environment one where the agent's successful execution accomplishes very little. The highest leverage single control is a network rule that blocks outbound traffic to the metadata endpoint, 169.254.169.254. One iptable's rule on your containers breaks the most common credential theft pivot at the network layer. If you run on EKS, Kubernetes network policy achieves the same thing. On GCP and Azure, the equivalent metadata addresses have the same control. When legitimate workloads need metadata access, the control shifts to credential scoping. IAM roles should carry time-bounded session tokens, not the default 12-hour expiry. Permissions should be resource-level ARNs, not wildcards. Condition keys like source IP or VPC endpoint restrict credential use to expected contexts. A stolen token scoped to one S3 bucket prefix and expiring in 15 minutes is nearly worthless to an agent that needs broad enumeration. Short time-to-live credentials function as a timing attack against the attacker's automation. The agent must complete the full chain, exfiltrate, persist, or pivot within the credential lifetime. A 15-minute window forces the agent to move faster, which makes its behavior more detectable. Rotate credentials on a schedule, not just after incidents. Any credentials cached from previous access expire before they can be used for post-compromise enumeration. Layer 2 is behavioral detection. The agent has a signature in your logs if you know what to look for. Enumeration velocity. A human AWS administrator makes a handful of CloudTrail calls per minute. A post-compromise agent makes dozens per second. The ratio between normal and post-compromise is detectable. A CloudTrail alert for more than 10 distinct API calls in under 10 seconds from a single identity is a practical starting threshold. Systematic breadth. Human access touches specific resources. Agent access enumerates all resources in scope. The pattern of listing every bucket, every prefix in each bucket, every secret in the secrets manager, that is not human access behavior. Absence of interactive gaps. Human access has pauses. The agent's API calls arrive in continuous streams with millisecond intervals. No pauses consistent with a human reading output. Specific detection rules worth building now. First, CloudTrail alert for metadata endpoint access within 30 seconds of a new container reaching a running state. Second, alert for more than 10 distinct list bucket calls in under 60 seconds from a single IAM identity. Third, enrich internal service call logs with user agent and forwarded for headers, and alert when user agent patterns deviate from your known service baselines. Layer 3 is response posture. The timing of an agent intrusion differs categorically from a human intrusion. An agent can exfiltrate within a minute of gaining credentials. Your response, starting with credential invalidation, must be at least partially automated. Detection triggers invalidation. You do not wait for a human to approve the action. Prescript the agent-driven intrusion runbook separately from your standard runbook. The forensic artifacts are different. Structured API call logs rather than bash history, consistent request formatting, no clipboard contents. The goal is not to be cleverer than the attacker's agent. The goal is to make the environment one where a clever agent cannot accomplish much. Full detection rules and IAM patterns at blog 261. Podcast P050. Shorts S166 and S167. Like and subscribe.